Hello kids. So today we are going to do the solutions for GJMAT 2021-22 grade 2 paper. Okay, before we start, let's go through and understand the format of the question paper. All right. Give me a second. All right. So we see here that the exam format, it has got 25 questions, multiple choice, single answer questions, 25 questions. Question number 1 to question number 10, it's on conceptual understanding. How clear are your concepts? So those are 2 marks each. Question number 11 to 20 is application ability. So those will have applications, okay, in form of word problems, which are 4 marks each. Question number 21 to 25, you have problem solving questions, which will have some non-routine questions and, mix of different concepts and different application in a problem. Those are 8 marks each. There is no negative marking. So you can attempt all the questions, MCQ questions. So before you do the solution, I would, before you go through the entire video, after each question, once the question is read, I would suggest that you pause the video and then you try to solve the question yourself and then watch the remaining of it. The type of questions are multiple choice questions as mentioned earlier, and the duration is 1 hour. So let's begin. Question 1, conceptual understanding from the conceptual understanding section, which are 2 marks each. Question 1, which of the following will have the same result as 13 minus 6? So 13 minus 6 is an expression, and let's see how much is that. So 13 minus 6, if you do, you will get 7, right? So which has got the same result? So 19 minus 13 gives you a 6. 3 plus 5 gives you a 8. 17 minus 8 will give you a 9. 11 minus 4 will give you a 7. And 5 plus 3 will also give you 8. So we can see you get a 7 only when you do 11 minus 4, which is also 7. So your correct answer is option D, 11 minus 4, which is 7. Let's go to the next question. Question 2. What will be the sum of smallest 6 different 2-digit odd numbers? So the question has got many conditions. We have to find the sum. So what we are looking for is the sum of what? We are looking for the sum of 6 different. So there are 6 of them. So there is condition 1. Condition 2, they are all different. And then they are, condition 3, they are 2-digit numbers, and they are also odd numbers. But we have to also have another condition, which is smallest. So there are 5 conditions altogether in this we are working on. So we'll start with the basic, which is a 2-digit number. So smallest 2-digit number is 10, but it is not odd. So the odd number is 11, right? So smallest 2-digit odd number is 11, okay? But then we have to add up 6 different of them, 6 different 2-digit odd numbers, which are the smallest. So we'll add the next smallest, which is 13. Then we'll add up 15. Then we'll add up 17. Then we'll add up 19. And we'll add up 21. All right. Now here we see that all these numbers have the same difference, which is of 2. Okay. So if you just notice here, we apply Gauss theory, where the numbers are in increasing order with same difference. So if you add 11 plus 21, you will get 32. Then if you add the 13 plus the 19, you will get another 32. And you add the 15 and the 17, you'll get another 32. So 32 plus 32 plus 32, which is also equal to 3 times 32 if you know multiplication. Else you can just add it up, you'll get 96. So your correct answer is option B, 96. Let's move to the next question. Question 3. Look at the clocks below and find the maximum biggest time difference if both the times shown are on the same day. So both, there are two clocks here which are shown, one on the left which is in white and the right one is a colorful one. Okay, they are showing two different times and it is asking you for the find the maximum biggest time difference. So you have to look at the difference, biggest time difference, all right? Now, these are both analog clocks. Analog clocks means that they can show the time, two times, because we know it's a 12-hour clock. So the time appears two times. For example, 6 a.m. in the morning and 6 p.m. in the evening, all right? So the 7 can be a 7 a.m., it can be 7 p.m., all right? So let's look at it. Let's say this is 7 a.m., okay, and this is 9 a.m. In that case, the difference here, as you can see, is only 2 hours. 7 a.m., then after 1 hour, it will be 8 a.m. After 1 hour, it will be 2. The difference is only 2 hours. All right. Now let's take it as 7 a.m. and this one as 9 p.m. This is in the night. Once it's almost, like your bedtime, around dinner time. So 7 a.m. to 9 p.m., 7 a.m. to 7 p.m. is 12 hours plus another 2 hours is 9 p.m. So that's 14 hours. Okay. The next one, we can look at it that we can say this is 7 p.m. and this is 9 a.m. Here, this time will happen first in the day. Okay. And then this one will happen later on. So 9 a.m. to 7 p.m. is 9 a.m. to 12 noon is 3 hours. And then from there till 7 p.m. is another 7 hours. So this is only 10 hours. Right. And the other combination could be again 7 p.m. to 9 p.m., which is again going to be a gap of only 2 hours in the evening. So we see that the largest time gap is 14 hours. If this one is in the morning and this one is in the night, or rather evening, then the time difference is the maximum, which is 14 hours. So the correct answer is option E, 14 hours. Let's move to the next question. Question 4. Use all the digits. These are digits 0, 1, 2, 3, only once to form two two-digit numbers such that the difference is minimum. Find the sum of those two numbers. Okay, so we have to use all the digits in such a way that the difference is minimum, but we have to find the sum of those two numbers also. Okay, so first of all, let's understand that how the differences of two numbers is there. It is based on, let's say, if you have a number, for example, if you take a number 30 and you take a 12, okay, here you see that the difference is of 2 tens, correct? Right, this is 2 tens more, but here it is 2 ones less. So the 30 has 2 tens more and 2 ones less. So the 30 has actually 20 minus 2, which is 18. It will be 18 more than this. You can see this. So in order to minimize the gap, you have to minimize the gap of the tens place, because that will have more impact for a difference or a sum to be more or less, correct? So what we need to do, we'll see here that the gap here of each one of them is 1. The difference between 0 and 1 is 1. The difference between 1 and 2 is also 1. But the difference between 2 and 3 is also 1. So there'll be at least a difference of 110 between the two numbers, right? So let's say the larger number is L and the smaller number is S. Okay, and here we have tens place and ones place. Okay, so here we can, in the larger number, we can have 1, and here we can have a 0. Okay, here we can have a 1 and a 0, or we can have a 2 and a 1, or yes, 2 and a 1, or a 3 and a 2. Right. So before we do that, let's understand that how the difference will come. Okay, so let's say the larger number's tens digit is this one. Okay, let's say it's T1. Okay, so the larger number's ones digit, the smaller number's ones digit, if it comes to as close to this tens place, and the larger number's ones digit comes to as close to this place, this gap will be least. Correct? So what we need to do is that we need to first try and use the smaller numbers ones digit as big as possible. So if we put this as 3 and this as 0, okay, then we can have a minimum gap here. Now we see the digits which are left here are 2 and 1. Okay, so we can put the larger digit here and the smaller digit here. And this satisfies our condition that the difference of the tens place digits between the two numbers is only 1. So 2 and 1 are left, so 2 minus 1 is 1. So we'll see that the difference here is 7. Okay, so this will be the minimum difference between the two numbers, okay, which is 7. Now, it is asking find the sum of the two numbers. So the sum of the two numbers which we used are 20 is number 1, which is larger number, and the smaller number is 13. So if we do a sum of these two numbers, our answer is 33, which is option B. Right? I hope you got this. Let's move to the next question. Question number 5. In how many ways, using different combination and or counts of coins, can you form exactly $20 using the below coins of $1, $2, $5, and $10 if you have 3 of each kind only? Okay, so let's understand this problem a little bit. So you have a sorry, not $1. These are all rupees, my mistake. Okay, so these are all Indian currency, which is rupees. So make 20 rupees using 1 rupee, 2 rupee, 5 rupee, and 10 rupee. So 1 rupee is the smallest denomination, 2 rupee is the next biggest, 5 rupees is the next biggest, and 10 rupees is the next biggest. All right. So we have to make 20 rupees and we have 3 of each. So the count of each one of them is 3 only. We have 3 of each coin. In how many different ways? Okay. So let's try and do this. Okay. So let's make a table here. We'll have to do a systematic listing. So we have a 1 rupee coin. We have a 2 rupee coin. We have a 5 rupee coin. And we have a 10 rupee coin. And their counts are, each one of them, we have 3 of them. And our aim is to make 20 rupees. Okay. Of course, we cannot make with 3 1 rupee coins, we cannot make 20 rupees. With 3 5 rupee coins also, we cannot make 20 rupees. We can make with 10 rupee coins. Okay. With using 2 of them. Okay. So let's understand number 1. So if we use 2 of this, okay, and we have 0 of these, then this is one of the ways we can make 20 rupees. So 2 times 20 rupees is 2 times 10 rupees is 20 rupees. All right. Now, what we are going to do is that we are going to replace that one of the tens with a 5 rupee coin. So we can have one of this, okay, one of this, and we can replace one 10 rupee coin with 2 5 rupee coin. This one will also give us 20 rupees. All right. The third way we can do is that we can have one of this, okay, and then we can have one of this, and then break up this 5 into 2 rupee and 1 rupee coin. So how we can do that? We can do that as we can have 2 of these and 1 of this. Okay. So that's 10 rupees plus 5, 15, 15 plus 2 times 2 is 4, 19 plus 1 is 20. Next one is that we can also break up this in this way. We can have one of this. So that's 10 plus 5, 15 plus 2, 17. And we can use all the 3 coins of 1 rupee denomination and we can make a 20. Right? So now we've used at least one 10 rupee coin and we see that we've got 4 ways. All right, to make this. Okay. Now let's try avoiding the 10 rupee coin completely. So if we use this thing and if we use, so we know that 2 times 3 is 6 and 1 times 3 is 3, 6 plus 3 is 9. So if we use only 2 of them, only 2 5 rupee coins, then we'll be able to make 10 plus 9, which is 19. So we need to use at least 3. So we'll use 3 of them and then we will make again another same thing. So what we did basically is that we took this one 10 rupee coin and we converted it into 2 5 rupee coins. So we got 3 here. And then we repeat the steps here, which are 2 and 1. And then we can have another one where we can say 0, 3, 1 and 3. All right. So we get how many ways? 1, 2, 3, 4, 5, 6 so far. Okay. Is there any other way to make a 10 rupee coin? We cannot have a $10 10 rupee coin and rest all 2 and 1 rupee coin, because then we will be able to make only 19. All right. So we get six ways here. If you see the list here, 1, 2, 3, 4, 5, and 6. And that should be your answer. So your correct answer is option D, which is 6. Right. Let's move on to the next question. Question 6. 9 identical same squares of side lengths. Identical means same, exactly the same. Okay, squares of side lengths 2 units. So these are called the side of the square. So there are 4 sides in each square. Okay, side length of 2 units. So these are 2 units each. Okay, 2 units each are joined to form a figure. Find the least possible length of the boundary, also called the perimeter of the figure. So these are all joined. Right now, these are all disjointed, as you can see. Okay, so if you have joined them, so there are 9 squares. Okay, so let's say if you have joined them in one line itself, 3, 4, 5, 6, 7, 8, 9. Now, what is going to happen is that you'll notice that these are all each 2. Okay, so 2 times 9. Okay, the one on the top of the figure, the entire length becomes 18. This is also 18, and then you have another 2 and another 2. So 18 plus 18 is 36 plus 2. This is 40. But this is still much more. If you notice what is happening, for each of the squares which are in the center, except these corner 2, okay, one of the sides is getting lost inside. Except, in fact, 2 of the sides. So this side is getting lost for this one, this square, and this side is also getting lost inside. Okay. So there are overall, if you look at it, 7 times 2 into each side length is 2. So you are losing out overall 14 times 2 is 28. You are losing 28 inside. And then these corner ones, they are losing one side each. So that's 2 times 2. So that's 4. So you're losing out 32. Overall, if you look at it, this has got a side length of 8. And 8 times 9 is 72. So 72 minus 32, you will get 40. And that's exactly what you got when you calculate it this way. So here the loss of the sides inside the figure, inside the composite figure, is much less. If you want to increase this, you need to make the figure as squarish as possible. If you join this, it will become a large square like this. It will become a large square like this. Now what is happening? The corner squares are losing 2 sides each inside, and the ones on this side, they are losing 3 sides each, and the one in the center, it is losing all its 4 sides. Okay, so here the length will be much lesser, and this is the configuration why when you have a particular perimeter of a rectangle. Okay, the largest area which they have is of a square. Okay, so given with a smaller perimeter, you can still have the same area. Okay, so here the perimeter is much less, but the area will be same. The area of this figure and the one which we made previously, the long one, okay, the long rectangle, both will be same because we are adding all the areas in each case. But here the perimeter will be much less. Perimeter is the boundary length. So let's look at it. So if we do 2 plus 2 plus 2, and we have 2, 2, 2 here, 2, 2, 2 here, and 2, 2, 2 here. We have 6 on each side. So 6 times 4, or 6 plus 6 plus 6 plus 6 will become 24. And that's your answer. So 24 is your answer. That will be your minimum possible length of the boundary of the figure. All right. So we'll move on to the next question. Question 7. How many different rectangles are there altogether in the below picture? All right. So here we see that these are rectangles. Understand one thing, that any square is also a rectangle. Okay. All rectangles are not squares, but all squares are also rectangles. So we have to count the rectangles basically. So in this, let's understand this, that what happens is that for a rectangle, you need, so let's look at this. So if we start from this line from here, okay, and we try to make a rectangle. So you have one rectangle like this, then you have two rectangle like this, and then you have three rectangle like this. If you start from this point, correct? All right, on the top row, in the top row, right? Like that, if you start from this line here, from this line, you'll be able to make one, and you'll be able to make two. Okay, and then if you start from here, you'll be able to make only one. So basically, in the top row, you'll be able to make 3 plus 2 plus 1. Right. Similarly, for the bottom row also, you'll be able to make 3 plus 2 plus 1. Okay, and if you take club all of this, you'll be able to make again 3 plus 2 plus 1. So if you take this like this, you'll be able to make 3 plus 2 plus 1. Right? So we can do it in such a way, let's understand this. In such a problem, what we need to do, we need to add 1, 2, and 3. That's 6. And 1 and 2, and that's 3. Okay, 1 plus 2 is 3. So 6 times 3 is equal to 18. You'll be able to make 18 rectangles from this. Okay, there is you can check it out also by sheer counting. Okay, and we can do it by doing simple counting. So the small ones. So let's name them A B C D E F. So the single rectangles, you have 6 of them, which are your A B C D E F. Correct. If you count the double ones, okay, when you double ones, so you'll have a AB, you'll have a BC, okay, you'll have a DE, and you'll have a EF, okay. Then you'll have a AD, you'll have a BE, and you'll have a CF. So how many did we get here? We got 6 plus 7, 13. Now let's look at let's look at 3 in a row. All right. So 3 in a row, you can notice you'll get a ABC and you'll get a DEF. So that's another 2. All right. And then if you do a 4-1, so you get a ABDE. Sorry. If you do a 4-1 in this shape, you'll notice you have a ABDE and you have a BECF. All right. So that's another 2. So how many did we get already? We've already got 6 plus 7, 13. 13 plus 2 is 15, plus 2 17. Now you cannot make a bit of 5. Okay, the next one is going to be all 6. And that's only 1. That's the entire thing, A, B, C, D, E, F. So that's 1. So if you add all of these numbers, okay, which is 6 plus 7 plus 2 plus 2 plus 1, you'll get 18. Right? But the easier way to do is just to, in a grid like this, you write 1, 2, 3, you add it up, you write 1, 2, that's 3. 6 times 3 is 18. Okay, because understand that every rectangle is a combination of a rectangle counted in a horizontal way and a rectangle counted in vertical way. For example, if we are talking about this rectangle here, so we are talking about when we said that when we start from here, we can do 1 and we can do a 2. So there are 2 rectangles which can be made. Okay. So we have 2 here, and we have and this one. So this is one of the rectangles, right? BCEF. So what we are doing, we are saying that, okay, this is one of the rectangles. So this was this rectangles and this rectangles combination, which is making this rectangle. All right. Okay. So this is how it is. Okay. So let's move on to the next question. So your correct answer in this particular question is option A, which is 18. right? So option A, 18. Is the correct answer. All right, let's move to the next question. All right, so very interesting question. In the picture below, the cat can only move along the rectangular grid path to reach the mouse. If the cat and mouse are at the opposite corners as shown, what is the shortest distance in units for the cat to travel to and catch the mouse? Assume that the mouse is not moving at all right? So let's make the diagram a little larger. This grid, this grid has got, the distances that's made up of a lot of rectangles. Now these rectangles are not squares here, and we see here that the length of two rectangles, and these are all aligned in the same way. Two rectangles is 6 units, given as 6 units. So each length here is 6 divided by 2, which is 3 units. All right. And the width of the rectangles, two widths are equal to 4 units. So the width of the rectangle is 2 units each, because 2 plus 2 is 4. Okay. So the cat, the shortest path, as I told you, it has come here. It has to travel these 5 lengths of rectangle and 3 widths of rectangles. So the total distance will be 3 times 5. This will be this, each one of them is 3 here. Okay, so 3 times 5, this length is 15 from this point to this point. And from this point to this point, it is going to be 2 times 3, which is 6. So the total minimum length will be 15 plus 6, which is 21. So your correct answer is option B. Very well. I'm very sorry about this question that I spent some time on this. I'll see if I can edit this video. All right. Okay. Question 9. What will be the sum of the first 20 numbers in the below pattern of one-digit numbers? Okay. So we see here that there is a pattern of numbers and it's asking for the sum for the total of the first 20 numbers. So the pattern goes 1, 5, 3, 4, 2, and then again 1, 5, 3, 4, 2, 1, 4, 2. So we see here that the pattern repeats after every 5 terms. And every 5 terms has got 1, 5, 3, 4, 2. Okay. Okay, so what is going to happen? This pattern's total, if you add it up, 1 plus 5 plus 3 plus 4 plus 2 comes to 15. And it's talking about 20 numbers. So this is 5 numbers. So how many sets of 5 numbers you need to make it 20? You need 4 sets, correct? 5 plus 5 plus 5 plus 5 is 20. So you need 4 sets. Now each set is 15. So therefore, the total of first 20 numbers will be 15 plus 15 plus 15 plus 15, which is 60. So your correct answer is option E, 60. All right. So let's move to the next question. In some 2-digit numbers, the tens place is smaller than the ones place digit. Find the difference between the largest such number and smallest such number. Okay. So we have to find the difference between the largest such number and smallest such number. So the tens place digit is smaller than the ones place digit. So which will be the smallest number? The smallest number, think about it, okay. If it's a 2-digit number, then the tens place digit cannot be 0. Correct? But you have to find the smallest number. So smallest number will have, in the tens place, it will have 10, at least 1. And therefore, because the ones place digit is more than the tens place digit, because tens place digit is smaller than the ones place digit, the ones place digit, for making the number smallest, you can have a 2 here. Okay. So this becomes your smallest number, right, which is 12. Now for the largest number, if you have a 9 here, you cannot have a 10 here, correct? In the ones place, because in any place value, you can have only a single digit. You cannot have 2 digits, right? So you cannot have a 9 here. You can have a 8 here, right? And therefore, over here, you can have a 9. Right? And it's asking you find the difference between the largest such number and smallest such number. So 89 minus 12 is 77. And therefore, your answer is option D. All right. So let's move on to the next question. We start with the application ability, that is question 11 to question 20, which are 4 marks each. So question 11, the sum of Peter's age and his younger sister's age is 24 and the difference of their ages is 14. How old Peter will be when his sister becomes a teenager, turns 13 years old? All right, so let's understand this, okay? So his younger sister age, okay? And so obviously if it's younger sister, sister is younger than this. So let's say Peter's age is this much, all right? And his sister's age is less than that. Okay, how much less? It is 14 less. Okay, so the difference between their age is 14 and the total is 24. Right? So let's first find their age. The reason we are trying to find their current age because we don't know their individual ages. Okay, in order to find out what will be Peter's age when his sister becomes 13, we need to find what is his sister's age. So that after how many years his sister will turn 13. And then we can add that number of years to Peter's current age also, right? So we need to find out first what are their current ages. Okay, all right. So now let's understand this. If I cut a 14 out of Peter's age, then I get double of his sister's age. So if I subtract 14 from here also, because I'm deducting 14 from Peter's age over here, I will get 10 here. So 2 times his sister's age is equal to 2 times his sister's age is equal to 10. Therefore, his sister's age is right now 5. Is equal to 5. Okay. So if his sister's age is 5 right now, we can check it out. Then Peter's age is 5 plus 14. That is 19 years. So 19 minus 5 is 14 and 19 plus 5 is 24. We can see this, right? Okay. So we found out. Now, after how many years his sister will move from a 5 to 13, which will become a teenager? That will be after 8 years, right? Because 5 plus 8 is 13. So Peter's age at that time, because Peter's current age is 19, so Peter's age at that time will be 19 plus 8, which is going to be 27. And therefore, your correct answer is option C, 27. All right? I've done it in a very complicated way, but we can do it in a much easier way. Okay, the question is very easy here because it says that the difference of their age is 14. So Peter is always going to be 14 years older than his sister because the difference of age will always remain sister. So how old will Peter will be? So if his sister turns 13, then Peter's age will be obviously 13 plus 14, which is 27. So if you are able to see this and you're able to connect with this is a much easier and simpler way to solve this with much lesser steps, right? Because if sister's age is 13, then it's going to be 27. So this thing about the sum of their current age does not matter. It does not matter at all in this question. Okay, this information is not very useful right now. Okay, because we need not find what are their current ages. We can just add 13 plus 14 and get the 27 of Peter's age. All right. The weight of 3 apples is equal to the weight of 2 mangoes. Okay, so we can see it over here. There are 3 apples here. There are 3 apples here. And it is equal to 2 mangoes. 2M, M stands for mango, A stands for apple. Okay. And one papaya is equal to 3 mangoes here. So the question is asking how many apples weight is equal to the weight of 4 papayas. So we have 1 papaya here. Okay. If we make it 4 papayas, so 1 papaya is equal to 3 mangoes. So if we do 4 papayas, which is equal to 1 papaya plus 1 papaya plus 1 papaya plus 1 papaya, that will be equal to 3 mangoes plus 3 mangoes plus 3 mangoes plus 3 mangoes. and that will be equal to 12 mangoes, right? Okay. Now 12 mangoes is same as saying 2 mangoes times 6 is equal to 12 mangoes, right? Okay. So here for every 2 mangoes, we have 3 apples. So we can say 3 apples times 6, if we do, we get 18 apples. So 18 apples will be also equal to 12 mangoes, and which will be equal to 4 papayas. So we see here that 4 papaya will be equal to 18 apples. All right. Just notice here, if we add 4 papayas here, we'll get 12 apples here. Sorry, 4 papayas, then we'll get 12 mangoes here. Okay, and 12 mangoes is 6 times of this, correct? Of this 2 mangoes. Therefore, it will be also 6 times of 3 apples, which will be 18 apples. Right. So we'll move on to the next question. Meera is 8th from the front in queue to buy entry tickets for the zoo. Gaurav is 10th from the back in the queue. If there are 3 other people standing between them, at least how many people are there in the queue? Okay, so let's understand this. Okay, so if Meera is 8th, eighth is Meera. Okay, and Gaurav is 10th from the back. So if we count from the back here, then Gaurav is here. Okay, if there are 3 more people standing between them, okay, find the least possible. So this is a very important and tricky condition. At least how many people are there in the queue? So understand, if we assume that Gaurav is behind Meera and we put here 3 people here, 3 people in between them, then the total number of people become 8 plus another 3. Okay, and plus including Gaurav, there are 10 people. Like here, we are including Meera, there are 8 people from the front of the queue. Then we have 3 people in between them, and then we get a total count. So we are basically adding in this all the positions. So we are getting 11 plus 10, which is 21. But is this the least? What if the 3 people are not on this side, but they are in front of Meera? What if Gaurav's position is here? So we'll have an overlap. So let's say this is another person in between, okay, over here. Another person here, another person here. And here where Gaurav is. So if Gaurav is here and he's 10th person from the back, so including Gaurav, there are 4 people from the front. Okay. And Gaurav is 10th from the back. So there are 9 people behind Gaurav. So 10 plus 9, sorry, 4 plus 9. You get four people are there, plus another 9. You get only 13 people. And 13 is more than 8. So there can be 13 people. So let's look at it. If you have 13 people here, 9, 10, 11, 12, and 13. Let's look at the position from the back of Gaurav. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You can see that Gaurav is here. Okay, so Gaurav can be in the 4th position. So if there is an overlap like this of the positions from the front and from the back, then the number of people become less. Correct? So number of people is 13 in this case. And that's going to be your answer, option C. All right, let's move to the next question. The price of bananas is 20 rupees a dozen, bunch of 12 bananas. So bananas are sold by the dozen also, and each bunch of 12 bananas, dozen is 12, 12 loose, 12 bananas, single bananas. So that costs 20 rupees. If you buy only by dozens, else, if you do not buy by dozens, if you buy loose bananas, like if you buy 3 bananas, 4 bananas like that, or 1 banana, 2 banana, then the bananas are sold at 2 rupees each. Okay. At most, how many bananas can Mrs. Reddy buy if she spends exactly 50 rupees? Okay, rupees is Indian currency. Okay. So let's understand this. Okay. If she's buying by dozens, so for 12 banana, she is paying 20 rupees. This is by dozens, by dozens. Okay. Now, if she's buying loose bananas, in that case, she's paying 2 rupees for each banana. So if she buys 12 bananas like this at this rate, at this price, then she'll be spending 2 times 12, which is 24 rupees. So which one is more expensive? Of course, this is more expensive and this is more economical or less expensive, right? So if something is less expensive and you have fixed amount of money, okay, you'll be able to get more of that. Correct or not? For example, if you have 10 rupees and if you buy pencils which cost 1 rupee each, you'll be able to buy 10 pencils. But if you buy 2 rupees each expensive pencil, you'll be able to get only 5 pencils. Right? So you need to buy for more quantity, you need to buy using the cheaper price, correct? Cheaper price so that you can buy more. So how many dozens can she buy? If she uses exactly 50 rupees. So 1 dozen is 20 rupees. So how many 20 rupees can go in 50 rupees completely? You'll be able to get 2 dozens because 20 plus 20 is 40. If you add another 20, it will go to 60, correct? So therefore, she is using only 50 rupees. So she's buying 2 dozens. So she's buying 2 dozens by dozens. And that will cost her 40 rupees and will give her 12 plus 12, which is 24 bananas. Now she's left with 10 rupees. Why? Because she's spent 50 rupees overall. So 50 minus 40 is 10 rupees. And for this 10 rupees, she is going to buy loose bananas. So 10 divided by 2 rupees, which is the price of each banana, you will get 5 bananas. Right? So overall, she bought 24 plus 5, which is 29 bananas. And that's your answer. So 29 bananas is option D. So 29 bananas is your correct answer. Let's move to the next question. Question number 15. There is a walking pathway around a circular park. Trees are planted every 10 meters along the entire pathway. Trees are numbered from the tree at the entrance of the park as number 1 and then in a clockwise direction in an increasing order. If the entire pathway is 200 meters long, find the shortest distance in meters between the second and the 15th path along way. Okay, so let's understand this. Okay, so let's draw a circle first. So let's say this is a circular park. All right. Now, let's say this is the entrance here. Entrance of the park is here. And this is the tree over here is number 1. Okay, so first let's understand that if the trees are 10 meters apart, so every tree, let's say this is tree 1, tree 2, the gap between them is 10 meters. And then the next one is tree 3, this is also 10 meters. Okay, so how many trees are there? So there'll be overall 200 divided by 10, there'll be overall 20 trees. Isn't it? If 10, 10, 10, how many times you will add to get 20? Let's take a smaller example. If I have 4 trees, 1, 2, 3, 4 in a circular way, and if I have 10 gap of 10 each, what do I see here? We get 40, right? So 40, the total distance, if you go one whole circle and you come back to tree 1, you cover 40 meters. So 40 divided by 10, by each distance, it tells me there are 4 trees. And there are 4 trees as we can see. Correct. So in this case, there are 20 trees altogether. So now let's understand this. So there are 20 trees. So let's mark this as 20 over here. The last tree is here. So we'll have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Okay. So anyways, my drawing is not that great, but there are 20 trees like this. Okay. Now let's understand this, that it is asking the shortest distance in meter between the second and the 15th tree along the pathway. The pathway is along the border. Okay. You cannot just cross like this. Okay. You just cannot cross like this. This is not allowed. All right. You need to go along the pathway. Between the second, now here is the second and here is the 15th. Okay, and it is asking for the shorter distance. Okay, so there are two ways to go. Either one can go this way, which is anti-clockwise, or one can go clockwise. So clockwise distance will be 15 minus 2, which is 13. Okay, so 15 minus 2 is 13, and 13 times 10 will be 130 meters. This is one distance. And the other distance, if you look at it, from 20 minus 5, 20 minus 5 is 20 minus 5 is 5. Okay, and you have then another two distances, 20 to 1 and 1 to 2. Okay, so 5 plus 2, which is 7 meters, 7. And 7 times 10 is only 70 meters. So which one is shorter? Of course, the 70 meters is less than 130 meters, so this distance is shorter. So if he goes anti-clockwise, if we calculate the distance between the 15th and the second tree, in this case, that will be a shorter distance, and that correct answer will be 70 meters, which is option D. All right. Okay, let's move to the next question. Question 16. Mr. Singh is traveling from Mumbai in India to Singapore by flight. Singapore is 2.5 hours ahead in time. His flight from Mumbai takes off at 10:30 a.m. India time, and the journey time is 5 hours and 30 minutes from Mumbai to Singapore. What will be the time as per Singapore time when his flight lands there? Okay, so we can do it in two different ways. One is that, let's say, we calculate the time first in terms of India time only. So he starts, his flight takes off at 10:30 a.m. Okay, flight time as we saw is 5 hours and 30 minutes. Okay, if we add it up, what will we get here? We'll get at 4 p.m. India time, he'll reach there, because 10:30 plus 1.5 hours is 12 noon, and then another 4 hours is 4 p.m. India time. And therefore, Singapore time at that time, that is SGT, will be 2.5 hours ahead, because they are ahead of us. Okay, because Singapore is in east to us, so Singapore's time is ahead of us, 2 hours and 30 minutes ahead in time. So 4 hours plus 4 p.m. plus 2:30, Singapore time will be 6:30 p.m. at that time. Okay. Second way to calculate this is that we convert this time only as Singapore time. Okay, the starting time itself. So starting time in that case will be 1 p.m. because when you add 10:30 plus 2:30 hours, okay, so 1 p.m. is starting as per Singapore time, and he takes 5.5 hours. If you add it up, you'll again get 6:30 p.m. Singapore time. Therefore, the correct answer is option B, which is 6:30 p.m. Singapore time. All right. So let's move to the next question. Question 17. In a parking lot, there are only two-wheelers, bikes and scooters, and four-wheelers parked. If the total vehicles are 20 and the total number of wheels are 50, then how many cars are there? Two-wheelers have two wheels and cars have four wheels each. Okay, this is a typical rabbit and chicken kind of a question where we solve by assumption. Okay, so the total number of vehicles, let's look at the conditions here and the information here. The total number of vehicles is 20. Okay, and the total number of wheels is 50. Okay, so if all 20 vehicles were bikes, okay, or two-wheelers, okay, then the number of wheels, total number of wheels would have been in that case 20 times 2, which is 40 wheels, right? When you take out one bike or two-wheeler, you take it out and you get a car in. one car in, is four-wheeler in. Okay, what happens? Your number of wheels goes down by -2 and you replace it by a car, so it goes up by +4. So overall, your wheels will go up by +4 -2, which is +2. When you replace one bike with one car, all right? So therefore, how many replacements do you need? Because your actual number of wheels is 40 wheels. Okay, and as per your assumption that all 20 vehicles are bikes, your wheels are 40. You make one replacement, you go to 42. You make two replacements, you'll go to 44, and so on and so forth. How many replacements you need to do is 50 wheels minus 40 wheels divided by the increase in wheels, which is 2 wheels. So that's 10 wheels divided by 2 wheels, and that's 5 replacements. 5 replacements. And those 5 replacements are all going to be cars now. So there are 5 cars overall. So we can check it out also. Okay, so if we have 5 cars, and therefore we will have 15 bikes, which is 20 minus 5. Because 20 was your total number of vehicles, minus the 5 cars, you'll get 15 bikes. Now let's calculate their number of wheels. So if you have 15 bikes, you will have 15 times 2, 30 wheels here. And for 5 cars, you'll have 5 times 4, you'll have 20 wheels here. And 20 plus 30, you get 50 wheels. So you get 50 wheels here, you get 20 vehicles here with a combination of 5 cars and 15 bikes, so everything is fine. All right, so you always should check your calculation. Okay, all right, so let's do the next question. Question 18. Sarika gave her 8 dolls to cousin Ritu. Now Ritu has 3 more dolls than Sarika, and altogether they have 31 dolls. How many dolls did Sarika have in the beginning before she gave her 8 dolls to Ritu? Okay, so let's understand this. Okay. Sorry. All right, so let's look at the after scenario here. After Sarika has given the dolls, after Sarika has given 8 dolls to Ritu. Okay. Now Ritu has 3 more dolls than Sarika. Let's look at the scenario. Okay, after scenario. All right. So you have a Sarika here. Okay, and you have a Ritu here. But Ritu now is 3 more than Sarika. Okay, after she has received the dolls. Now overall they have 31 dolls. Okay, so the dolls will always, the overall dolls will remain the same, either before or after. Doesn't matter, right? Because the dolls are being transferred between each other. Nobody else is taking the dolls, right? So the dolls are either with them or with her. So if you add them up, you get the same number of dolls. Now let's look at it. Okay, Ritu has 3 more dolls than this. So if I take out this 3 dolls from Ritu, which means the total number of dolls in that case will be 28. Correct? And this will be equal to Sarika's number of dolls. Now, double of Sarika's dolls is equal to, okay, so 2 times of Sarika's dolls is equal to 28. Therefore, Sarika's dolls is 28's half. Half of 28, or 28 divided by 2, which is equal to 14. Okay, so we can check this also. So if you have 14 dolls here, therefore Ritu will have 14 plus 3, 17 dolls. So 14 plus 17 is 31, right? Okay, now let's look at Sarika. Sarika had initially some dolls. She gave 8 dolls to Ritu, and therefore now she has 14 dolls only. Therefore, before she gave the dolls, if we undo the subtraction by adding the 8 back, 14 plus 8, 22 dolls. So Sarika had 22 dolls, correct? And therefore, Ritu would have had in the beginning 31 minus 22, 9 dolls. So if Ritu gets 8 dolls, 9 plus 8, Ritu will reach 17, which is 3 more. If you notice, the total here is also 31, here also is 31. The difference here is 3. Okay, and there's a transfer of 8 dolls from Sarika to Ritu. Okay, all right. So let's move to the next question. All right. Students of grade 1 of Global International School voted for their favorite pet animal. All students voted, and a pictograph of the votes by the children was made where each picture of the voted animals, dog, cat, fish, and bunny, represented a certain number of students. The total number of students who voted for cat and fish were 4 less than the total number of students who voted for dog and bunny. How many students were there in the class? Okay, so first let's understand this, that each one of them represents us, each picture represents a same number of students. That's what is given. Right? So we look at this, the total number of students who voted for cat and fish. So cat we can see here, cat we have 3 of them. And fish we have 1, 2, 3, 4, 5. We have 5 of them. The dogs we have 6 pictures. And for the bunny we have 4. Correct? So if we add cat and fish, we get 8. And if we add these two, we get 10. Okay. So we see that a difference of 2 pictures, 10 minus 8, which is the difference of bunny plus dog, as compared to cat and fish, which is 10 minus 8, these two, okay, is 2. So 2 pictures, the difference of 2 pictures is equal to 4 students. Okay, which means 1 picture. So two pictures, okay, they represent 4 students. Therefore, 1 picture will represent 2 students. And its question is asking how many students were there in the class. So overall, if you add all this up, you get 10 plus 8, which is 18. Okay, so the number of students in the class, there are 18 pictures. So 18 pictures will be equal to 18 times 2, because 1 picture is equal to 2 students, will give you 36 students. So the class had 36 students. The correct answer is option D. All right, so let's move to the next one. The banyan tree and the pine tree have altogether 40 birds sitting on them. Right, 5 birds flew far away from each of the trees. Okay, so these are the things which are happening. All together have 40 birds. And 8 birds flew from the banyan tree to the pine tree, and 6 birds flew from the pine tree to the banyan tree. Now they have equal number of birds. Find the number of birds sitting on the banyan tree at the beginning. Okay. So let's understand first that the banyan tree plus the pine tree initially were 40. Okay. Later on, that the banyan tree plus the pine tree, after 5 birds flew away from each of the trees, they became 40 minus 5 minus 5, because both the trees had loss of 5 birds each. So they had 30 birds. Now, if after the transfer of birds between the two trees, some birds like, from the banyan tree, 8 birds flew this side, okay, and from the pine tree, 6 birds flew this side, okay, birds. What would happen? The number of birds were equal. So 30 divided by 2 is 15 birds. So now each one of them has 15 birds each. This is at the end. So now if you have to find out the number of birds in the banyan tree had in the beginning, let's do it in a working backward way. Okay. So let's say banyan tree has these many birds. Okay. First 5 birds flew away. Okay. So it went through a transformation and it lost 5 birds, and there'll be a number here. Okay. Then 8 birds went to the pine tree. So it lost further 8 birds. Okay. And then another 6 birds flew from the pine tree to the banyan tree. And now The banyan tree also has 15 birds. Okay. If we undo all this, so if the birds had not flown from pine tree to the banyan tree would have had -9 birds. Okay. Now, if the birds from the banyan tree had not flown to the pine tree, the banyan tree would have had more birds, which would be 17. So you add the 8 back, you reverse the process. And then if no birds had flown from the banyan tree, flown away, in that case, the banyan tree would have had 5 more birds. So the banyan tree would have had 17 plus 5, which is 22. Right. So the correct answer is option E, 22. Right. Let's do the next question. What is the least number of cuts required to cut a cake in 8 equal pieces? So this is a little tricky question. It's a 3-dimensional figure. All right. So if you have a cake like this, you might think that, okay, if I cut it once like this, I'll get 2 pieces. Cut like this, I'll get 3 pieces. Then again from the center, 3 pieces, 6 pieces. Again from this, like 8 pieces. However, it is asking the least number of cuts. Okay. And equal pieces. So what you can do in that case is that, let's say you have the cake like this. Okay. First cut, you do a cut off from the top. Okay. Okay. Let's say along the length, and then you at 90 degree you do another cut. So now you have 4 pieces. Let's say you have not taken them apart, and then if you cut a cut which is horizontal cut, not a vertical cut from up to down, not this way, like these 2 cuts are from up to down. Let's say you do a cut which is horizontal. Horizontally you slice the cake, then you will get 8 slices. So 4 bottom slices will be similar to this, and 4 top slices will be this. So the number of cuts is required is 3 only. This is option E. All right. So let's move to the next one. Find the value of A plus B plus C for the following cryptorhythm if A, B, and C are all different digits and none of them is 0. Okay, so none of them is 0. It's already given. So something plus something is equal to 0. 2 digits. We all know that this is going to be the same thing if you're adding. So 2 times what will give you a 0 in the ones place. So that's going to be 5. So B is going to be 5. You know that for sure. Okay, because either B was 0 or B would have been 5. But B cannot be 0 because the question says none of them is 0. So B is 5. So you get a 10 and you get a 0 here, and 1 gets carried forward. Now you add 1 plus A plus C, and that is giving you a 5. Correct? Therefore, A plus C is equal to, this is 5. This is 5 also. So A plus C is equal to 4. All right, because A plus C is 4 plus this 1 carry forward will give you a 5. Okay, so A plus C is 4. And therefore, the question is asking A plus B plus C, and the value will be 5 plus 4, which is 9. Hence, your answer is option A, 9. All right, so let's move to the next question. At a Christmas party, Santa was giving out balls to the children. Every child got at least 1 ball, but each child could take more and up to a maximum of 3 balls. Santa ball came in only 2 colors, white or red. If no 2 kids got exactly similar balls by count and color combination, so it's not by count or color combination, count and color combination, then at most how many children were there at a Christmas party? So in this case, this is again a pigeonhole principle problem. We need to count the combinations. Now we need to understand that the balls are of 2 types. Okay, the balls are of 2 types, white and I guess it's red. Correct. And the number of balls kid can take is either a 1 or a 2 or a 3. Okay, so we'll try to look at the combination for all of this. So if it is 1 ball combination, then there is either a white or a red. Correct. So therefore there are overall 2 possibilities, 2 combinations. If it is a 2 ball combination, then it can be either a white, a red, or a red, white. So there are three possible combinations. All right. Now, if it is a 3-ball combination, then let's understand this, what we can get here. We can get here either a white, 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 or a red, 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 or somebody might have got a 1 white and 2 reds, okay, or 2 whites and 1 red. So overall, there are 4 combinations. Okay, so overall, if you look at it, all these are different. Okay, none of them are exactly the same. Correct. So now overall, the number of combinations are 9. So if no 2 children got the same combination, exactly the same balls, no 2 got exactly similar balls, then maximum how many kids are there? So maximum will be 9. 4 plus 3 plus 2, which is 9. Because now the 10th kid will have to go in one of these combinations. Okay, so the maximum number of kids will be 9, which is option D. Because 4 plus 3 plus 2, 9. So there are 9 combinations. So if I put the kids, if I assume that one kid, the first kid got white, the second kid took red, the third kid took white, white, the fourth kid took red, red. We are trying to avoid the situation where any 2 kids are getting the same combination by giving every kid a new combination. But we run out of combinations after 9 combinations, and then we'll have to repeat a combination. And then 2 kids will have the same combination. So therefore, the maximum number of kids will be 9. Okay, all right. So let's move to the next question. Question 24. There are 9 identical looking coins, but one of them is a fake coin and lighter in weight than the rest. Okay, so they look identical, but one of them is a little lighter and it is lighter than the rest. At least how many weighings on balance scale are required to be done to find the fake one? Okay, so we have the knowledge that it is lighter. Okay, so many people do a mistake in this, that they take 2, 2, 4, 4 coins. Okay, so let's see what will happen. Okay, so if we put on the balance 4 coins here and 4 coins here, and let's say the fake one is here in this one. Okay, in the balance. Okay, so this one will go up and this one will go down because this one is lighter. Okay, then you'll have to do one more weighing. Now you'll split, now these 4 coins are not required, these are not fake ones, so you'll use these 4. Okay, so you'll put 2 coins here and 2 coins here, and let's say this time the fake one is in this one. So this one goes up and this one goes down. Okay, so therefore you are left with these 2 coins. So you'll do another weighing. Correct? Because now this one is not required anymore, so you will use 1 coin here and 1 coin here, and whichever goes up is your fake coin. So you're looking at 3 weighings, but is this the optimal way of doing the thing? The optimal way to do is that you need to do this. Okay, I'm sorry, you had 9 coins, right? So you had done, so 1 coin was left in the first case. So if you are very lucky, if these 2 are equal in one weighing only, you will find that the one which you left out was the lighter one. Otherwise, the lighter one will come in one of those. Okay, which is very likely that will come in one of those, because 8 coins, you are picking up any 8 coins, that will be much more likely. Okay, so anyways, you will require 3 weighings minimum in a bad scenario. Now let's look at a 3 coin scenario. So if you take 3 coins each on each side, so you leave out 3 coins and you take 3 coins each. Okay, if you take 3 coins each, in that case, let's say if this is lighter, okay, then you take 2 coins each and you leave one of the coins from here aside, and you take 2 coins from these, because this one is now not required if this is lighter. Okay, and you put 1 coin each. If this one is lighter or this one is lighter, that one will be the fake coin. If these 2 are equal, then this is the fake coin. So in 2 weighings only you are able to find this. But let's say what happens if these 2 are equal in the first weighing, then again we do the same thing. For the second weighing, we use these 3 points, which we had kept aside, and we use only 2 of them. Again, the same thing. So in 2 weighings itself, you'll be able to figure out which is the fake coin in this. Okay, the lighter one will go up. If they are equal, then the third coin is the fake one. Okay, all right. So if you apply logic in two weighings itself, you'll be able to figure out the fake coin. So correct answer is option B. All right, so let's do the last one. In a particular year, for the month of January, there were 3 Sundays on even numbered dates. Which day is the 1st of February in that year? Okay. So let's understand this question. It's a very interesting question. Let's make a calendar here first. So January, as we all know, has 31 days. So we'll start with a Sunday, the calendar, then Monday, Tuesday, Wednesday, Thursday, Friday, and a Saturday. All right. Now let's understand. Sunday has even numbered dates, three of them. So what date it will be? Okay. So let's understand in any calendar. Let's say if I put 1 here. Okay. The next Sunday will be after 7 days, which is 8. The next Sunday will be over here, will be 15 plus 7, 22 and 29. Okay, how many? We see that the numbers go in a sequence of odd, even. 1 is odd, 8 is even, 15 is odd, 22 is even, 29 is odd. So they go in a sequence of even, odd, because you're adding an odd number every time, which is 7. Correct. So normally you notice that these dates in a calendar will be 31, and the rest of these days will be 4 of them. Okay, they will have 4 days each, 4 dates each. These 4 days, Wednesday, Thursday, Friday, Saturday, will have 4 dates each if the calendar is in this way. Correct. But the first and the second, they are almost repeated in the days which are on the first and second, they are almost repeated in every month except February. Okay, because the 29 and 30th also fall on them, because this one will be 2, 9, 16, 29, 23 and 30. Right, and then the months which have 31 days will also have the third date. The third date day also gets 31 also. So that also has 5 dates. Okay, so 3 plus 10 plus 17 plus 24 plus 31. This is how it is. But here, if you notice, the sequence is odd, even, odd, even, odd. So there are 3 odds. Then the second one has even, odd, even, odd, even. It has got 3 evens. And this one again, it has got odd, even, odd. This one again has got 3 odds and 2 evens. But you need 3 even number dates. Therefore, your Sunday, we need to shift this. Okay, so we'll just delete this part. Okay, and we need to shift the day 2 over there. All right, so day 2 here, we'll put it over here. If we have day 2 here, then we know that then this will be 9, 16, 23 and 30. This one will be 31. So you might be wondering, where is 1 gone? So there'll be 1 row above this, and 1 will be here on Saturday. Okay, so 1, 2, 3, then 31. Over here you'll get 3, sorry. Won't be 31 here. You'll have 3 here, and so on. 3, 10, 17, 24 and 31. Next one will be 4, 11. 11 plus 7 is 18, 25. That's it. Right? And so on and so forth. And Saturday will have here 1 ke baad it will come here 7, 1, 7, 1, 8, 15, 22 and 29. Okay. So there'll be 1 more row above here, in fact. And here it will be all blank. And here the dates Here the dates will be of December before January, because this is a January calendar. So we see here that there are three even numbers, 2, 16, and 30. Okay. All the days which get 4 dates will always have two even and 2 odds. Okay. Only the first, second, and third can have 5 dates, and 3 of them can be odd or even, and the other will have 2 odd or even. Okay. So the question is asking you, what is the 1st of February? So we can see here the 30th will be a Sunday also, 30th of January. 31st of January will be a Monday. And therefore, 1st of February here will come here as on Tuesday. So the correct answer is Tuesday, B. All right. So that brings us to the end of the paper. Hope you enjoyed it. Sorry for a little mistake in one of the questions where I kind of went on a different tangent, but anyways, I've explained that to you. So my recommendation would be to pause the video, okay, after I've read the question, and then try to solve it yourself. You can solve it using some other method also. That's absolutely fine, as long as your method is logical. Every problem can be solved in 10 different ways. Okay, as long as the logic and the maths involved over there and the concepts involved are correct, it's absolutely fine. All right. Thank you very much for your time.